Hello there, my students. These videos are about how we do rational functions, at least here at Harlan High School in San Antonio, Texas, in the United States of America. Okay? The letters we're going to use are R, A, T, E, and Y. So even though your teacher at your school in your country might use different letters, it's basically all the same stuff. Okay? Which we're going to talk about right now. So here are what these letters, R, A, T, E, and Y, stand for. Okay, so once again, your teacher might use different vocabulary as far as the letters go, but this is just one way to organize the information that we're going to find in order to be able to graph a rational function. Okay, so the R, we're going to find the R first, just because it makes a word. R stands for the roots. The roots are your x-intercepts. Okay, and it tells you exactly what to do, and that's set your numerator equal to 0 and solve for x. Okay, so when we're looking for your x-intercepts, we are looking at the numerator. Okay, just the numerator, whatever it happens to be there. Notice the numerator can never equal 0, so none is a perfectly fine answer for the roots. Okay, none is a good answer. That means it doesn't have an x-intercept. The graph does not cross the x-axis, which is perfectly fine for our rational function to not cross the x-axis. Okay, so if there's nothing in the numerator, as we will see in some examples, then we're going to have no x-intercepts, and none is the correct answer. Okay, the A part of RATEY stands for your vertical asymptotes, the vertical asymptotes of your function. And that comes from your denominator. You set your denominator equal to 0 and solve. Okay, like it says, factoring if needed. Okay, so we'll go to these other things about removable discontinuities and other things, graphing holes later. But just know that it always comes from your denominator. The things that can be excluded, right? Your domain restrictions always come from your denominator, be it a vertical asymptote or a removable discontinuity, which is also called a hole. So that's the A part, the vertical asymptotes. Okay, and then we have the T. The T is making a table around the vertical asymptotes. Okay, we're going to make a table to see, does the graph go up or does the graph go down, right? So here maybe we have a graph and we have a vertical asymptote here. So we're trying to decide, does our graph approach infinity or does our graph approach negative infinity? Okay, so we're looking for the left side of your asymptote, and we're going to do a calculation for the right side of the asymptote. And we're going to do this using the table. Okay, so the answers we're going to have are negative infinity, meaning the graph goes down, and positive infinity, meaning the graph goes up. Okay, all positive answers go down, up. All positive answers go up, and all negative answers go down. But we'll see what that means in practice here in a couple minutes. Okay, so T means make a table. E stands for end behavior, okay, which really means the horizontal asymptotes. Okay, what are the y values approaching for very large values of x? Okay, when we get to calculus, we're going to call that limits as x approaches infinity. Okay, the limit as x approaches infinity is the y value of the function, right, the horizontal asymptotes. Okay, so there's three things we're looking for. Is your rational equation top-heavy? Is your rational equation neutral? So we're going to call this neutral. It says same degree, but I like the word neutral better. So is it top-heavy? Is it neutral? Or is it bottom-heavy? Okay, so when we're doing this, we're looking at the degrees of the exponent. So maybe like x cubed over x squared. Right? That would be a top-heavy rational function because the numerator has a 3 as the exponent and the denominator has a 2 as the exponent. Okay? So that means there are no horizontal asymptotes and we have to do something else to find the oblique. Okay, but that's not going to happen until later. Okay, if it's neutral, right, if we have an x squared over an x squared as example, right, neutral, the power in the top is the same as the power in the bottom. Right, your degrees are the same. Then you look at your leading coefficients. Okay, and so it's a y equals something, depending on your coefficients. Okay, so we have some examples of that also today. And then if it's bottom heavy, that means we have a larger denominator. The power in the denominator is larger. Okay, so this one is a 2 in the denominator, and that one is a 1. So if the degree of the exponent in the denominator is larger, it's called bottom heavy, and we always have a horizontal asymptote at y equals 0. Okay, every single time, it's always y equals 0 as the horizontal asymptote. So there's E, your horizontal asymptotic behavior, and then the y is your y-intercept. You simply plug in 0 and solve for y. Right? Plug in 0 for all the x's, and you're going to get it as an ordered pair. So an x comma y, 0 comma y. Right? 0 comma y is where it crosses the y-axis. So R, A, T, E, and Y, those are the letters that we're going to solve or calculate every single time we do a rational equation problem. So let's jump in and see some examples. Here's our first example. Now remember, we're trying to graph this. The whole entire point of this unit, the whole entire point of RATEY is so that we can graph this rational function. So first, what are the x-intercepts, right? R means roots. What are the x-intercepts? So we're looking at the numerator, right? The x-intercepts only come from the numerator. Is there a variable in the numerator that we can solve? Right? No, there's nothing up here. Nothing, no variable, nothing except for a number, the number 1, which means we have no x-intercepts. There's nothing to solve up here. Right? Your roots always come and only come from your numerator. So the fact that we have a 1 means that it does not going to cross the x-axis. There's no x-intercepts. Okay, A, the vertical asymptotes. We use the denominator for that, just the denominator. X plus 2, we set it equal to 0. And we solve for x by subtracting 2 from both sides. So we have a vertical asymptote at -2. Okay, now remember, this is the equation for our vertical asymptote. So we come down here to your graph. You put 2 tick marks to the left, right, representing -2. And we put in a vertically dashed line to represent this asymptote. Okay, now remember, it's not really there. If we had a graphing calculator and you were to graph this in here, you wouldn't see a vertically dashed line. Okay, you would see probably nothing whatsoever. But for us, we're going to use this as our visual so that we can, remember that it's there, I guess. So there's your vertical asymptote. That is the A part of your RATEY. Now our table. We want to know what's going on to the left and to the right of -2. Okay, so we're going to do this kind of a horizontal table. And we pick a number very close to -2, but to the left of it. Like, even closer than -3. How about -2.1? Like very close. Like stalkerish close. Like -2.1. Super duper close. Okay, and we also pick a number very close to the right of -2. Like -1.9, right? The closer we get, the better, right? But of course, the more decimals we throw into our equation, the more tedious the calculations are. So I think a 0.1 is pretty okay. And what we do is we plug that into your equation. So 1 over -2.1 plus 2. Okay, you replace x in your equation with that value that we just chose. Okay, now, the important thing is this a positive or a negative number? 1 over -0.1, right? So -2.1 plus 2 is -0.1, which turns out to be -10, by the way. But the important part is that it's negative. So if we have a negative value, that means your arrow is going to point down on the left side of your asymptote. Okay, so we're looking at what is the graph doing, the asymptotic behavior. On the left side of the asymptote, the graph is going to point down. Okay, and the closer and closer we get to -2, the further and further negative our value is going to be. Okay, which is why 1/10 is pretty good. Okay, let's plug in -1.9 and see what we get. 1 over negative 1.9 plus 2 is 1 over positive 0.1, which is positive 10. So because we have a positive value, our graph is going to go up, right? It's going to go up to infinity on the right side of your asymptote. So remember, we're doing all this work so that we can sketch a graph. So as we get closer and closer and closer to our asymptote, our y values are getting larger and larger and larger, right? They go up to infinity. Horizontal asymptote end behavior. So let's look. Is it top heavy, bottom heavy, or neutral? Okay, so we have how many x to the what power on top? Right, so x to the 0 on top. Believe it or not, what's x to the 0? Nope, it's 1. Anything to the 0 power is 1. So there's x to the 0 over x to the first. So is this top heavy, bottom heavy, or neutral? Bottom heavy. By the fact that there's no x on top, right? No visible x on top, it is going to be a bottom heavy graph. And a bottom heavy graph has what as its horizontal asymptotic equation? Right? Because bottom heavy is not the answer to our problem. The answer is the equation for your horizontal asymptote. And every bottom heavy graph has y equals 0 as the equation of its horizontal asymptote. Okay, so bottom heavy is not the answer. Y equals 0 is the answer, and we put a dashed line. Right, you probably can't see it on your paper because your paper is written with a pen or pencil. You can't even really see it with my blue line. But there we have our y equals 0 horizontal asymptote. And lastly, we have to find the y-intercept. So let's plug in 0 for x. That's 1 over 0 plus 2, which is positive 1/2. So the graph will cross the y-axis at positive 1/2. So technically 0, 1/2 if we're going to write it as a coordinate. So we do all of that just so we can graph it. Okay, so our graph is going to start off, let's see, where should we start? Let's start at the left. No, let's start at the asymptote. Okay, so we know that it has to be close to 0 here. So we're going to come down on the right side, basically pretty vertical, and then we're going to start curving and hit negative 1/2. And then we're going to go pretty horizontal as we go out to the right and approach 0. Okay, so this is the top right quadrant of our graph. Right, it will not cross your vertical asymptote, so it goes up on the right side and it has to go through 1/2. And then on the left side, we start down and we basically come up vertically. We make a little curve and we end up going horizontally to the left. Okay, so that would be a sketch of the graph of 1 over x plus 2, which is our answer, right? All of the answers are using all of these properties in order to sketch the graph. So now we're done, and let's look at another example. So here's example number 2 from our little booklet. We have x minus 2 over x plus 4. So the roots come from your numerator. X minus 2 equals 0. So when we add 2 to both sides, x equals positive 2. Remember, that's your x-intercept. So when we come down to our graph, we put 2 tick marks to the right, and you put a circle on the x-axis, right? With closed dot, that is where it's going to cross the x-axis. Okay, this time we actually have an x-intercept. Okay, and then we go up. Now we find the vertical asymptote, which is just your denominator. So we only use the denominator for our vertical asymptote. Set it equal to 0 and solve. So we get x equals negative 4 as the equation of your vertical asymptote. So we go 1, 2, 3, 4 units left. And we put in our vertically dashed line to represent the asymptote. Now our table, negative 4 is your asymptote, right? So I make a vertically dashed line to remind myself. Now I pick a little bit to the left, negative 4.1, and a little bit to the right, negative 3.9. Okay, so that's a little bit to the left of negative 4 and a little bit to the right of negative 4. And I'm seeing whether this is a positive or a negative number when I plug it into my equation. So on the top, I get negative 6.1, and on the bottom, I get negative 0.1. Okay, so in my brain, what is a negative divided by a negative? It's a positive value. Yes, it's positive 61, but it's positive. So on the left side of my asymptote, my graph goes up, which is what I need, right? That's the important part, is the graph goes up. And then I do the same thing for negative 3.9. So on top, I get negative 5.9, and on the bottom, I get positive 0.1, okay, which is all well and good, but the fact remains that now this is a negative number, right? Negative 5.9 divided by 0.1 is negative 59, of course, says the calculator, which means our graph goes down. The negative means our graph arrow points down on the right side of your asymptote. And that's what we want to know. Is the arrow going up to infinity if it's positive, and is the arrow going down to negative infinity if it's negative? Okay, horizontal, right? What type of a function is this? It's x minus 2 on top and x plus 4 on bottom, so this is a neutrally heavy graph, right? We have x on top, a single x over a single x. X over x is the same, right? Not x squared, not x cubed. It's neutral, so then we look at your coefficients. What is the coefficient of the top x? 1. What is the coefficient of the bottom x? 1. So 1 divided by 1 is 1. So we have a y equals 1 horizontal asymptote. So we come up 1 unit and you make your horizontal line go on forever. As long as you have a graph arrow, then you have to make your horizontal line. Make it go on there forever. So because it's neutral, right, we have an x over x, x to the first over x to the first. That is a neutrally heavy. It's the same power on top and bottom. So we have y equals 1. And now lastly, we have your y-intercept. Where does that thing cross your y-axis? So we plug in 0 for x. 0 minus 2 over 0 minus plus 4 is negative 1/2, right? 2 over 4 reduces to negative 1/2. So as a coordinate, that's 0, comma, negative 1/2. And if we put a 1 on there about even, you can put your negative 1/2 in there like that. So our graph has to go through our points, but also to that arrow. So we're going to start on the right side and come up through, right? Do your best to hit negative 1/2, and then positive 2, and then go on out towards your y equals 1 horizontal asymptote. Okay, the curviness of the curve I'm not really concerned about. Just the fact that it goes through your points. And then on the upper left side, right, there's beautiful symmetry and mirrorism going on here. So the mirror of that bottom right quadrant is going to be reversed in the top left quadrant. Okay, so it doesn't cross your vertical asymptote and it approaches your horizontal asymptote out to the right. Okay, here's a little bit more involved example, right? Because it has an x on top and an x squared on bottom. But we can still do this. Okay, R stands for roots. So we look at the numerator, right? It always comes from the numerator. 2x equals 0. 2 times some number equals 0. So that means x equals 0, right? Because we divide both sides by 2. 0 divided by 2 is 0. So it crosses our axis at the origin. Pretty nice. Okay, vertical asymptotes. We turn to your denominator, and we solve your denominator. X squared minus 4 equals 0. Okay, so this one's going to be a little bit more involved. We add 4 to both sides. X squared equals positive 4. And I square root everything. And how many answers do I get? 2 answers. I get a positive 2 and also a negative 2, right? Very important to know that when you take the square roots here in algebra, you get positives and negatives. So we have a vertical asymptote at negative 2 and a vertical asymptote at positive 2. Just like that. So now we need to make our table, and we're going to make our table with 2 separate values. So we have negative 2 and we have positive 2. Okay, so we have 4 calculations to make. What's going on to the left at negative 2.1 and then negative 1.9. And then on the right side, what's going on at positive 1.9 and positive 2.1. So we're going to plug all 4 of these into our equations and see whether we get positives or negatives. So we get our signs, right? So the sign to the left is a negative. The sign to the right of negative 2 is positive. The sign to the left of positive 2 is negative, and the sign to the right of positive 2 is positive. So let's go down and put these onto our graphs. We are on the left side, and then the right side, and then we're on the left side, and we're on the right side. Okay, end behavior. Let's look at the end behavior, right? So is this graph, is this equation top heavy or bottom heavy? This is a bottom heavy graph. We have x squared on the bottom and we have an x on top. So it's bottom heavy, which means we automatically have a y equals 0 horizontal asymptote. So right here through your x-axis, we have your horizontal asymptote. And then lastly, your y-intercept, 2 times 0 over 0 squared minus 4 is 0 over minus 4, which is 0. So naturally it crosses here already. Okay, so let's talk about how we now sketch this. So we're going to start at the down arrow to the left of negative 2. So it's going to come up and curve and go to the left, right? Not crossing your horizontal asymptote. In the middle is where it does something strange. So we start on the high side and then we come down, and it probably looks like a cubic, right? Something like this. And then it goes down off of that side. And then in that first quadrant, it's going to curve and point out to the right. Okay, so as we do more and more and more of these graphs will become more familiar to you, and you'll not be as confused by what they do. Okay? So watch for video number 2 over 4, 5, and 6. Bye, y'all.